now let's use the exact same equation, but let's actually take a look at a rational function. So just determine the slope of the tangent to this rational function. So we've seen a polynomial, we're going to see a rational now, and we're going to take a look at a radical as well, because all different approaches to this, okay? So let's go m equals, and let's go the limit as h approaches 0. Okay, so first we're going to take this equation and we're going to sub in x plus h. Okay, so we're going to go 3x plus h plus 6 over x plus h, and then we're going to subtract the original, so 3x plus 6 over just normal x. And this is all divided by h. Now, this is super ugly because it's like a fraction divided by something, so it's like three numbers on top of each other. We're going to get rid of that immediately. Okay, so in this step, I'm going to sub in the x equals 2. So we have 2 plus h plus 6, and then 2 plus h, and we're going to have minus 2 plus 6 over 2. And instead of writing it divided by h, we're going to actually just write it beside divided by h. And in the next line, you'll see why that's really, really convenient, okay? So now let's do the limit as h approaches 0, and yes, every single line you have to write the limit as h approaches 0. Let's expand this, okay? So we have 6 plus 3h plus 6 over 2 plus h, and then 3 and 3 is 6, 6 and 6 is 12, 12 divided by 2 is 6. Okay, again, bracket that entire top. Now, instead of writing divided by h, we can't divide by a number, we can't divide fractions by a number, but what we can do is we can multiply it by the reciprocal, 1 over h. Okay, so let's go limit as h approaches 0. This gives us 12 plus 3h over 2 plus h. Now, in order to add the negative 6, we have to multiply by 2 plus h over 2 plus h, because we need that common denominator. So 6, 2 plus h over 2 plus h. Now they have the same common denominator. We can collect the like terms on the top, or collect the terms on the top, because again they're same denominator. So let's leave the 2 plus h on the bottom. Okay, 12 plus 3h, let's leave it. Okay, so let's go negative 6 times 2 is negative 12. Negative 6 times h is negative 6h. Okay, and this is going to be multiplied by, again, 1 over h. Okay, this is where it starts to get nice and pretty. 12s cancel out. 3h minus 6h is negative 3h over 2 plus h. But if this is multiplied by 1 over h, these two h's can cancel out. Therefore, what are we left with? We're left with the limit as h approaches 0 of negative 3 over 2 plus h. Remember, you cannot cancel out this h because it's not factored. It's not multiplied or divided. It's added. So you cannot cancel it out. It must be multiplied or divided. Okay, and we're left with the limit as h approaches 0, negative 3 over 2 plus h. Now, we're going to sub in. So sub in h equals 0. And this is where we drop this limit. So negative 3 over 2 plus 0. I get negative 3 over 2. In other words, negative 1.5. So the slope of the tangent to this rational function is negative 1.5. Okay, last example. Find the slope of the tangent to f at x equals root x at x equals 9. Okay, so the exact same steps for this one. We're going to write root x plus h minus root x, and then that's going to be all over h. Oops, I forgot the limit as h approaches 0. That is not good. Okay, there we go. Okay, now the limit as h approaches 0, let's actually sub in the x equals 9. Okay, so let's go 9 plus h minus root 9 all over h. Okay, Root 9, that's pretty, that's just 3. Now, from section 8.1, so from the last section, we know that we can't really do anything with this 9 plus h, like the square root, because it has a radical. So what we're actually going to do is we're going to multiply by the conjugate, okay? 9 plus h, and then instead of plus 3, we're going to go, or instead of minus 3, we're going to go plus 3. And we're going to multiply that by root 9 plus h plus 3. Okay, so what do we get on the top? Root 9 plus h times root 9 plus h is just simply going to be 9 plus h. I'm going to ignore the two middle terms, and negative 3 times 3 is negative 9. And that's all going to be over. Do not even expand this. It will, 9 times out of 10, cancel out and be really pretty. Okay, so I'm just going to write the h right here, and then this denominator right here, and they're just multiplied by each other. So let's cancel out the 9s. What do we have left? We have h over h, root 9 plus h, plus 3. Cancel out the h's. Okay, I get 1 over root 9 plus h plus 3. In this case, it's okay that we have an h in the denominator because it's not alone. So if we just have an h in the denominator, when we sub in that h equals 0, it's going to give us a 0, which we can't have. But because there are other numbers in the denominator, it's going to work out. So let's plug it in. So remember, as soon as we plug in the 0, we no longer write the limit. 9 plus 0 plus 3. Root 9 plus 0 is just 3. So I get 1 over 6. So the slope of the tangent to root x is 1 over 6 at x equals 9.